This is my 4-bit microprocessor. Each location within the PROM code has one specific instruction and is executed sequentially because of the counter and the clock. Half of those output bits make up the opcode. Here it is a 1 for the instruction decoder, which determines what the rest of the process does with the control bits. The other half goes as data values into the data mux, which then selects either the data from the PROM or the data from the ALU accumulator to be forwarded into the register file. The ALU receives data from the register file, and if needed, it can make use of all the different functions. It has an accumulator, which is a register that stores the output data from the addition, the subtraction, the OR, and or XOR operations, whenever the write enable is high. Here's my 4-bit register subcircuit and the 1-bit register. So to also be able to do hardware subtraction, I added this input pin and modified the 4-bit full adder with XOR gates. If the control bit is enabled with a 1, the XOR gates create the invert of the B inputs. Together with the 1, which serves as a add 1 on the carry-in, we can create the 2's complement and therefore do the hardware version of subtraction. On low, it does addition as usual. Here are the subcircuits, the OR, the AND, and the XOR operations. The register file consists of 2 registers. In one of the 2 registers at a time, the data received from the mux can be stored depending on the control inputs. Here it is within register 0. The register subcircuits are the same as the ALU register, but here is the red decoder for the selection. Finally, the output of the register file goes as ASCII code into the ASCII display, so we can read the code in as a user-friendly way whenever the control input is enabled. Every instruction is executed sequentially, as you can see, as the clock is going. And so it starts with hello, Brother Davies, BD. Then we have some addition, where each hex code is first stored individually in the registers and then sent to the display. And then we have an addition, where we're making use of the add function and also storing within the accumulator, and to then later on be displayed as well. The same goes with the multiplication, since 3 by 3 is the same as 3 plus 3 plus 3. And then we also are doing subtraction, which is this kind here is the software subtract, where I first convert a plus 3 with the XOR, and then the add operations of the ALU. And then I add the 4 to the -3, and then receive a 1, which then has to be converted to ASCII code, and then it displays here. The last one is a hardware subtraction, as I've already mentioned earlier within the subcircuit.